This is a video endoscope. Come here, Shubha. Come here. And this is the video endoscope which I am holding in my hand here. And you see, I can hold the entire scope in my one hand. This is the first thing which we should start doing. Whenever you are holding a scope, try to hold that entire scope in your one hand or like this. What you should not be doing is letting them hang freely like that. This should not be hanging here freely like, or this end should not be hanging freely down like this. Okay? Why? Because this insertion tube is very, very delicate. It can go and hit against something and it can get damaged. There is a lens here, there is a CCD here, it can get damaged. Similarly, if this heavy bulky end is dangling down, it can go and either hit somebody or something, and it can again also get damaged or cause injuries. So always hold the scopes like this in your one hand, whether it is upper or lower. They are different in their dimensions in their legs, but you can still hold the entire scope here securely in your one hand. So that this is securely held in your grip. There is no chance of any injury or damage to the scope. Now let's look at the various parts of this scope. So see here, this is the entire scope in front of you, and just for the sake of understanding, we divide it into three parts. So this long tube, which is going to be inserted into the patient while doing the scopy, is referred to as the insertion tube. This part, which I am going to hold here and do my endoscopy, is the body of the scope. Get it? And then the other end of the scope, the other end of the scope, which is going from the body and gets connected into the rest of the equipments, which is going to be your light source and the image processor. This is known as, or referred to as, the umbilical cord of your scope, because it acts like an umbilical cord and it connects the entire scope to the image processor and the light source. Okay, so we are going to discuss all these three parts separately one by one, starting with the insertion tube here. So this is the long insertion tube, and this is what goes into the patient. That's why we are calling it insertion tube. And if you see here, there are certain numbered markings here on the sheath of this insertion tube. Can you, even if you can't read, can you see there's a number written here? This is 20, and then this is 30 and 40 and 50 and 60 and so on, till you reach the other end of this insertion tube where it is written 100 centimeters. This is 100. So the length of this insertion tube is 100 centimeters. And when we say what is the length of your scope, we are only referring to this length. We are not talking about the length of the entire scope. Okay? Length of the scope means the length of the insertion tube, and this is 100 centimeters. So if you see here, this is 20 and then this is 30, and in between these two numbered markings, you have another marking which is not numbered, but it is midway, so I know if this is 20 and this is 30, this is 25. Okay, this is 25. And if you see, the first numbered marking is 20, this is the tip of the scope. From the tip, the first numbered marking here is 20, so this is 15, isn't it? The 10 is not mentioned here. 10 is not mentioned here. But we know where 10 is. In this part, if you see that there is no, it appears to be metallic, that is because the sheath has been removed to show you what is inside. Actually, the entire scope has a sheath here also, right up till the tip. See that? So if you look carefully, you can make out in this scope also that this 10 centimeter, the sheath is dull, of a slightly different color as compared to the rest of the sheath. Can you appreciate that? The same thing is going to happen here also in this scope. The distal most 10 centimeter of your scopes behaves differently also. It has a slightly different colored sheath also. Black or slightly different shape. That's to differentiate it from the rest of the scope. This distal 10 centimeters is the bending section of your scope. And you can angulate it. You can bend it in 4 directions. See, I can bend it in left and right and up and down position. Okay? All this angulation is done. The controls are there in the body. Let's understand the insertion tube, then I will talk about the controls. So, this is the distalmost 10 centimeter, the bending section of your scope. And from there you can have these numbered and non-numbered markings going all the way to the other end. The purpose of these markings is to help you comment upon the distance at which you see that lesion. When you are doing an endoscopy and you see a lesion somewhere in the esophagus, you can comment precisely that I see a lesion at such and such distance from their incisors. Okay? So, when you are doing an endoscopy, what do you need to see inside? Again, we discussed it earlier, we need light. What else? While doing an endoscopy, you need a lens system to capture the image, to see the image. What else do you need? You need insufflation, so you need a mechanism to instill air or CO2 sometimes you use. What else? Suction. You need a channel for suctioning out. There may be fluid, there may be blood, secretions. You may have irrigated lavage and now you want to suck out the fluid. What else? Working channel. You need a working channel through which you can introduce your accessories and do your procedure, biopsies, sclerotherapy, polypectomy, intraoperative. Anything else? One more thing is required. Sometimes the tip here, which has the lens, that lens on the tip could also be smudged. There could be blood, there could be secretions. Just as in your laparoscopy, if the tip of your telescope is smudged, what do? Take it out immediately, clean it and again put it. You can do that in laparoscopy. You can't do that in endoscopy. You are somewhere half the length into the colon or in the duodenum and in the veins. You can't just keep coming out and cleaning the lens. Isn't it? You can't do that. So you need a mechanism to clean the lens also. All these features are present here at the tip of the lens. Again, the controls are there in the body. The controls are going to be here in this body. We'll come to that. So if you look at the tip of this scope, later on all of you are going to handle it, use it, and again show it to you. You have a lens here, lens. And for the light on either side of the lens, there are 2 light bundles or light guides. How is light reaching here to the tip? It is coming from the light source. How? It's the same optical fibers which you have in your laparoscopic light cables also. Same optical fibers, because this is also a flexible scope. And starting from that other end, all that light will be transmitted and through the optical bundles and the light will come here. Okay? It will reach here. And there are 2 light bundles, one on either side of the lens. Can you see this one shiny spot at the tip? Can you at least see that one shiny spot? The brightest spot. This is the nozzle actually. This is a small metallic nozzle. Okay? And this is known as the air-water nozzle. Air-water nozzle. Because when you need to insufflate, then that air which you are going to instill is going to come out from that nozzle. And when you need to clean the lens of your scope, then a jet of water or saline will come which will clean the lens. So it has dual functions. That is why it is known as air-water nozzle. Okay? What else is present? There is one channel present here. And this is the working channel. All your accessories which you are going to introduce from here, this part, this is the biopsy channel. You introduce it from here, it is going to come out from here, the tip of the scope. So this channel is running all along the length of your insertion tube, and you introduce your accessories, it comes out from here. What about the suction channel? The same channel is for suctioning and irrigation also. Same channel. So see here, this scope is actually a piece of engineering. Within this small diameter of the scope, the upper ear scopes are usually like 9.5 to 9.8 millimeters. That's less than a centimeter of diameter, this scope. And it has all these engineering fitting inside this. It is only possible because each of these features is doing dual functions. That nozzle which is there is serving both for air insufflation and for water jet. That same channel is working for your biopsy or any other accessory or for suction irrigation also. Okay? So there are 5 things on which are present, isn't it? There is one lens. On either side of the lens there is 2 light guides or light bundles. There is one air water nozzle and there is one channel which we call as a biopsy channel, which will also serve as a suctioning channel. Okay? All these things are present here. So if you have this biopsy forceps or any accessory like this, you are going to introduce it from this curve, from the biopsy channel. So we will show you, and then it is going to come out from the tip. Now understand something. This is your routine upper GI base model. So would be your colonoscope or a ERCP scope. They have all the scopes, they have the same basic features. But now that I am planning to take a biopsy from here, but at the same time I also want to clean that area by either irrigation, or at the same time I also want to do suctioning also. Now that suctioning is not going to be effective because there is only one channel, and right now that channel is being occupied by a accessory. It could be any accessory, isn't it? So this scope has no other option for me. Either I can do suction irrigation or use an accessory through that channel. But many a time you have a bleeding ulcer there. Before you could put a clip on it, or before you could inject and stop that bleeding, you need to have a clear view of that field also. For that you will need to lavage it properly. How will you do that? So this is a base model of the scope, but many other scopes, they have an auxiliary water channel. In addition to all this, you have an auxiliary water channel through which you can connect a water pump. Because now, otherwise, what is the way to irrigate or clean some area? You will routinely, what you will do, you will take a 50 or 100 cc syringe and push that saline through this channel, and it will clean that area. But while doing the procedure when the accessories inside, you can't do that. So additional accessories are available, like an auxiliary water channel, like a water pump. You connect it to that auxiliary channel, you press the foot pedal, and now you will have a jet of water coming. You can use an accessory also, and from that auxiliary channel, you can have a good field view also. Okay? So this is about your insertion. Okay? And let us come to the body of the scope and see this here. This is from where you introduce all your accessories. This is the biopsy channel. We call it a biopsy channel. Basically, it's a working channel. You can introduce any accessory from it. But see, if I am going to introduce my accessory from here like this, that accessory can still work. But the issue is this. There is a slight gap between the accessory and that working channel. Same issue which you would face if you are using your diagnostic instrument through a cannula which does not have a washer. Isn't it? Isn't it? It's the same scenario. What will happen now? I am trying to insufflate and open up the lumen, and because this is not airtight, a little bit of air would be coming back around that biopsy channel, it can keep on leaking from it. My insufflation may not be effective. That is why we always use this biopsy valve. See this biopsy valve? It is not a washer, but now we have a valve. We always use this biopsy valve here before we introduce any accessory. So this is just mounted here like this, and this is disposable, because ideally you should be using a new one. And whenever you want to introduce accessory, then you simply open it. Accessories goes from here. And this is air, isn't it? Now no escaping of air is going to happen. And when you are not using any accessory, just keep it closed like this. Again, no leakage, backflow of air or CO2 would happen. Okay? This is your biopsy. Okay? So now let's talk about this body of the scope. This is where all the controls are. This is where all the controls. So see what is present. There are two wheels, the small wheel and big wheel. Can you appreciate in the image? Can you see clearly? This is the small wheel and this is the big wheel. So there are two wheels, and these are the angulating wheels of your scope. So I told that the bending section of the scope can be angulated in two directions. See, it is coming up and then it is going down. I am doing this by rotating the big wheel. Okay, and there are only two ways in which you can rotate the wheel, clockwise or anti-clockwise. When you rotate it clockwise, like this, you are basically going down. And when you are doing it up, anti-clockwise, the scope looks up. Okay, so big wheel is for up and down angulation. Similarly, the small wheel is for left and right angulation. Okay, so it is for left, or now it is going towards my right. It is going towards my left. Small wheel is for left and right, big wheel is for up and down angulation. So in the beginning, even if you don't remember, there is no need to worry which one was which direction should I rotate. It is mentioned here on the wheels itself. Okay, in the big wheel there is a D with a pointer this way. That means you rotate it this way, which is clockwise and it will look down, and anti-clockwise it will look up. Similarly, the left and right wheel, this is right, clockwise, and anti-clockwise is left. Okay, see here. This is left and this is right. Okay. So four directions of angulation is controlled by these two wheels. And these two wheels work independently of each other. You can rotate the big wheel to any angulation and you can rotate the small wheel to any angulation. They are independent of each other. And that allows you to look at every possible angle using the scope, isn't it? I can look at any possible angle, left and right, up and down. If I combine these four angulations together, see, I can angulate the scope in any direction. There. And this allows me to have a panoramic view and examine the entire lumen of the hollow viscous. Supposing I am doing endoscopy and at one particular angulation of left and right like this, I see that there is a lesion. And now I want to focus on that lesion or do some therapeutic procedure. For that, I have to keep on maintaining this angulation. Okay. So you don't have to hold the wheels here. While doing a therapeutic procedure, your mind should not be at the wheel. It should be on the lesion. So both the wheels, they have their individual locks. I have locked the scope in that particular angulation. See that? It will stay like this. I don't have to keep on holding the wheels like this. Later on, I can simply unlock and the scope slowly comes back to its normal neutral position. This is the straight normal neutral position of the scope. It comes back. So it has two locks. So see, this is the knob for the small wheel. This is the lock. This lever is the lock for the big wheel. You can lock the wheels at any degree of angulation. Okay. This is how you control the angulation of the bending section. Now besides that, see here these two buttons. These are detachable buttons, first of all. See, I can detach these two buttons. And these are the only detachable parts of this scope besides your biopsy channel. I have removed these two buttons. You can remove and you should remove it while you are cleaning and disinfecting your scope. Okay? So between the two, This red one is the upper and this blue one is the lower. What is the function? Upper button is for suctioning. Both of these buttons are spring loaded. So as long as I press this button with my fingertip, I can press it like this. This will activate the suctioning. Okay. So as long as you want suctioning, I keep it pressed. I lift my finger, it comes out again and the suctioning stops. Upper button is for suctioning. Lower button, the blue one, and if you look carefully, there is a small hole here in the center of this button. There is no hole in this button, a small hole right there. This button is for showing you at the tip. When you want insufflation, you have to use this button. When you want a jet of water to clean the lens, again you have to use it. How? See here. Once your fingertip covers that hole here, don't have to press it. Just cover that hole. Cover this button with your fingertip. You will have a jet of air now coming from the tip of that nozzle. Only insufflation will happen. And when you want a jet of water to clean the lens, then you press the button. As long as you keep it pressed, a jet of water will come and clean the lens. Okay? It will clean the lens. You know that air water nozzle which is present is very, very fine, less than a millimeter in size. And it is not straight nozzle like this. It is actually bent here at right angles. And it is facing the lens. Facing the lens. If it was straight, the jet of water is going to go and shoot away. I want it to fall on my lens, which is present here. So the nozzle is 90 degrees. It's very small. But when I press it, a jet of water comes and falls on this lens and cleans it. Just like the windscreens of your car, where you can clean your windscreens with a jet of water coming, exactly the same concept. So for air, you cover it. For water, you press it. Okay? So these are the two buttons here. Now besides that, if you see, there is another button here. This one is fixed. And if I rotate the scope, there is another button present here also. If I further rotate, you can see two more buttons here. Okay, so you have four more buttons. 1, 2, 3 and 4. 1, 2, 3 and 4. These are the programming buttons of your endoscope. Just like you have programming buttons on your camera heads, isn't it? You could control your white balance and your magnification and your freeze and your brightness and your aperture size. Similarly, you can assign 4 functions to these buttons also. Again, programming buttons. You can assign the freeze function here, you can assign the white balance here, you can assign magnification here. You can assign 4 functions, and now you know every time you want to freeze the image, you press this button. For white balance, you can press this button. Okay? So these 4 are, so all the controls of the scope are present here. Okay? Then, this is the umbilical cord of the scope. So the purpose of this is to connect and complete all the pathways. So there are certain things which are coming from the tip and going towards the apparatus. And there are certain things which are coming from this side and going to the tip of the scope. Light is coming from the light source here and then going to the tip of the scope. Isn't it? Air and water both are going to come from here and go to the tip of the nozzle. Isn't it? Suctioning when you do is going to come from the tip and go here to the suction machine. The electromagnetic signals, isn't it? For creating the image. This scope also contains a CCD. Just like your camera has. I told you this is a modern video endoscope. So where is the CCD? That CCD is located near the tip of the scope. See here. I told you there is a lens here. Just behind the lens here is present the CCD at this level. That CCD is present. So all the reflected light goes through that lens, falls on that CCD, and from here the signals are generated, and they travel along the length through this umbilical cord, and this is connected to the image processor. Okay? So the umbilical cord basically completes the pathways for all these things. So look here, what all is present here. This is the nozzle for air. Your air goes from here. This long nozzle is for the light. The light coming from the light source comes from here. And you know, that means you will also have to use a light source for endoscopy. But the light source for endoscopy is different from that which you use in laparoscopy. Because this light source has an additional pump. That air which you are going to use for insufflation or water jet which you are going to use for cleaning the lens, that will not flow on its own. It will be under pressure. So you need a pump for that. So in endoscopic light source, air water pump is also present in that light source. So the two are basically a single unit. Okay? So this is where the light is going to come from. This is from where the air goes. And what about this saline which you are using or water which you are using to clean the lens? Where is that going to come from? These two nozzles here. But these are the nozzles. Where is that going to come from? Every endoscopy base unit, it has this additional water bottle. So you fill it with sterile water or you fill it with normal saline, and this is connected onto the side of your image processor, and this end of the bottle is connected here to these two nozzles. As I told you, these two nozzles. Okay, so connected here like this, and now when I press that button or cover it, I will have air or water. And this is the channel where you connect the suction. All the pathways are complete. Suctioning, water nozzle, air, light. What is remaining? The signals which are going to come from here, they have to reach the image processor so that it can generate the image and project it onto the monitor. So how will the signals go from here to the image processor? See, this is an electronic scope, isn't it? It has a CCD. Unlike your earlier fiber optic scopes which are purely optical, there was no electronics there. Here, these video endoscopes are electronic scopes. So the signals which reach here from the tip, from the CCD, they have to move from here to the image processor. For that, connecting the two, you use this, which is known as a pigtail, just because of its shape. And this pigtail completes the pathway like this. On one end, it is connected to the umbilical cord, and similarly, this end goes and gets attached to the image processor. Okay? So now the electronic signals can go from here and reach the image processor. Okay? So this is how you use these features, and these are the various parts of your scope. This is a base model design. Every scope will basically have the same kind of feature.